Okay, so we are at 93 and f of x given as 4x squared plus 1, g of x is x plus 1, and we are asked to find, in number A, we are asked to find f plus g function. Okay, now here we need to find a new function, f plus g function. Since you have a positive plus here, you are adding these two functions. Okay, so f plus g function is f of x plus g of x. You substitute your f of x for x squared plus 1 plus g of x is x plus 1. Try to have your answer in a simplest form. So we have like terms here. This is 4x squared plus x plus 2. This is f plus g function. Next, you are asked to find f minus g of x. So you have a minus here. So you find the difference of these two functions. So this is f of x minus g of x. You substitute f of x. 4x squared plus 1 minus g of x, which is x plus 1. You have more than one term, so make sure to have parentheses. This is 4x squared plus 1. You distribute negative. So negative times positive x, negative times positive 1, negative 1. This is 0. We have 4x squared minus x. The next, you are asked to find f times g of x. The sign is multiplication. So you multiply f of x and g of x.
Sorry to bug, but I don't think the screen is sharing. At least I can't see it on my side.
Oh, thank you. Oh, let me share my screen. I thought I saved my screen. Oh, someone had a comment here. Yes, that's right. I didn't share my screen. Thank you. Uh, can you see now?
Yeah.
There we go.
Okay, great. Okay, just let me redo all these. Okay, number 93. Okay. So here, basically what I did here is that, so we are asked to find f plus g function. Since you have a positive sign here, so you are adding f function and g function. Okay. Next, you are asked to find f minus g. You have a negative sign, so you subtract these two functions, f of x minus g of x. Okay, do you think I need to redo these two A and B? Is it okay if I skip or you want me redo A and B?
I think it's okay. Straightforward, yeah.
Okay, now let's go to this one. So here in part C, we are asked to find f times g function. Okay, so we have a product here. So you are multiplying f function and g function. So our f function is 4x squared plus 1. And g function is x plus 1. So use the FOIL method and simplify, okay? This is for you. The last one is f over g function. This is asked. So now here we have a division here. So you are dividing f function by g of x function. So f function is 4x squared plus 1. G function is x plus 1. Now let me add here one more. So what if we have like this? What is this? What kind of function are we asked to find? Is it a multiplication sign? How do we read this? Can anyone read this expression? Can you read this?
Isn't it f of g?
No.
F composite.
F composite g, and the definition is f of g. Okay, so this is not multiplication. Okay, you are not multiplying. This is f composite g function. So this is composite function, and the definition is f of g of x. This is the definition. So you just replace your composite by the parenthesis and you have the definition, and you have to find this expression. Now let's find it. So let's substitute g of x. We have f as it is. G of x is x plus 1. Okay. Now you find f of x plus 1. And to find this one, you substitute x plus 1 for every x in f function. Your f function is given us to as 4x squared plus 1. So you're going to substitute this expression for every x in f function. So you substitute for every x in f function. So we have 4 as it is. For x, you're going to substitute x plus 1. We have square plus 1. Okay, and this is same as 4 times x plus 1 square is x plus 1 times x plus 1 plus 1. And I want you to simplify and have the final answer. Okay, and when you substitute, there is no more f. Okay, f is gone. And you'll be asked to find the composite function. You will have pretty similar, okay, like this example 93, you will have this 4. Okay, you will be asked to find 4 for this expression. You'll be asked to find f plus g, f minus c, f times g, f over g, and f composite g. Okay, you will be asked. The function may be different, but you will be asked to find these 4 things. Okay, do you have any question, or do you need any help with this one, 93? Okay, looks like none. Okay, let's go to 97. So 97, yeah, it's the same. Okay, you have a different function. In 97, you have a different function, and you are finding f plus c, f minus c, f times g, f over g, f composite g. So I'm going to skip 97. So let's do 99. In 99, yeah, it's pretty okay. Now in 99, you have the table. So let me draw that table. So you have a x, f of x. When x is -4, f of x is -1. When x is -2, f of x is 0. When x is 3, f of x is -2. This is one table. And next table we have x and g of x. So when x is -1, g of x is -2. When x is 0, g of x is 0. When x is 3, g of x is 5. And in 99, we are asked to find f composite g of -1. Okay, this is a composite. So use the definition. Definition is f of g of -1. Now, from this table, can you tell me what is g of -1? Who can tell me g of -1 from the table? So g function is here. So g of -1, when your x is -1, when x is -1, g of -1 is -2. So you substitute -2, f as it is, -2. Now you find f of -2. You have this table. So when your x is -2, f of -2 is 0, and 0 is the final answer. Any question for number 99? Okay, looks like you don't have. Let's go to 100. 101 is pretty similar. Okay, you can do this one. 103. Okay, so in 103, it's pretty similar to the one that we just did. Let me see. So 103, 105, 107. Okay. 103, 105, 107. So in 103, so you are asked to find f plus g of 4. Can you find this 100? How do we find f? It's very similar. We had f plus g of x, okay? And now instead of x, you have 4. But you have the plus sign between two functions. So you are adding f of 4, not f of x now. F of 4 and g of 4. G of 4. Okay, you are given f function. Your f function is given as 3x minus 1, and g function is given as negative 2 square root of x. Now, what is f of 4? How we find f of 4? You substitute 4 for every x in the f function. So 3 times 4, 12 minus 1, 11 plus g of 4. You substitute 4 for every x in a g function. This is g function. You substitute 4. So negative 2 times square root of 4, which is 2. So we have negative 4. And this is 7. And in the similar way, 105, 107. So in 105, you have f over g of 2. So you have a division here. So this is f of 2 over g of 2. Find f of 2, find g of 2. Okay? This you should be able to solve this one. And in 107 is a composite, the one we just did. F composite g of negative 1. So this is composite, not multiplication. So use the definition. So f of g of negative 1. So you find g of negative 1. You substitute here. Whatever you get, find f of that number and you get the final answer. Is it okay with you all with these examples? Or do you want me to do in detail? Does anyone need help here? Okay, looks like none of you need help, so I'm gonna go to the next number. So we did 107. Okay, 109. Let's see what I have here. 109. In 109, yeah, it's a composite, same thing with a different, like instead of negative 1, you have positive 9. So you can do that 109. 111. Let's see what we have here. 111. You are asked to find, yeah, you are asked to find f composite g, g composite f. Yeah, I think I'm gonna skip this one too. Okay, so here you have a f of x given as negative x squared plus 4. G of x is given as x minus 2. And you are asked to find f composite g of x. Use the definition, that is f of g of x. Okay, you substitute g of x. F as it is, g of x is x minus 2. Now find f of x minus 2. So you substitute x minus 2 for every x in your f function, in this f function. So for every x, you're going to substitute x minus 2. So we have negative as it is. Then x squared, for x, you're going to substitute x minus 2. Make sure parenthesis square plus 4. Simplify, you get the final answer. And similarly, there is g composite f. Okay, and this is g of x. Sorry, g of f of x. So g of f of x. So you substitute f of x first. G as it is. F of x is negative x squared plus 4. Now you substitute this expression for every x in g function. Your g function is x minus 2. So for x, you're going to substitute negative x squared plus 4, and you have minus 2. You simplify and you get the final answer. It's very similar. Okay, if you have any questions, please let me know. So 100, like now 16, 19, 120. So we have 116, 119, 120. Okay, let's see what we have in 116. 116, yeah, it's a different function, but f composite g, g composite f. Okay, I'm gonna skip this one. 116, 119, yes. Out of 119 and 20, you will have one. Okay, you will be asked to find the difference quotient for sure. So we have, so I'm gonna do one. Okay, so I'll do 119 and 120 is for you. So 119, our function f of x is 4x minus 3. So this is the function and you are asked to find the difference quotient. And finding difference quotient means you are finding f of x plus h minus f of x divided by h. So this is, so you have to find this expression, and you will be given this, okay? You are not required to memorize this. You will be given to you, okay? Now, f function is given to us, and we are finding the difference quotient. Now, in the difference quotient, so let's see, we need to, so we already have f of x, which is 4x minus 3. What we don't have f of x plus h. So let's find f of x plus h first. So f of x plus h. How do we find? You substitute this expression x plus h for every x in your f function. So for every x, you're going to substitute x plus h. 4 as it is. For x, you're going to have x plus h minus 3. Okay, you simplify. This is 4x plus 4h minus 3. Now, we have f of x plus h. We have f of x. You substitute here. So this is, so for f of x plus h, we have 4x plus 4h minus 3, then negative f of x. F of x is 4x minus 3. You have the two terms, so make sure parenthesis 4x minus 3 divided by, see, divided by h. Let's simplify this. 4x plus 4h minus 3, distribute negative. Negative times positive 4x, negative 4x, negative times negative 3, positive 3 divided by h. Now, okay, now positive 3, negative 3 gone, and positive 4x, negative 4x gone. So we have positive 4h divided by h, and this is h is gone. We have 4 as a final answer. And you will have one difference quotient, okay? You will be asked to find one difference quotient. The function may be different. You may not get exactly 4x minus 3, but you will have one. And I'm skipping 120, okay? That's for you. Okay. Do you have any question up to, okay, this was the end of section 2.7, okay? So we finish up to 2.7 from 2.3. Now we have one more section left. Now, does anyone have question from 2.3 to 2.7? Okay, good. Now let's go to our last section. That's section 4.1, okay. Section 4.1. Okay, so in section 4.1, so number 12, 14, okay, what, 19. Okay, number 12 and 14 is the same, so I'm gonna do one, okay? You have a different function, but the problem is same. You're asked to verify that these functions are inverse of each other. So in number 12, our f of x is negative 8x and g of x is negative 1 over 8x. And I will give you a hint here, okay? You are asked to verify that f function and g function are inverse of each other. And how we know? In order to be an inverse of each other, so what we're gonna do here is that you have to find f composite g of x. You find f composite g of x, okay, like the way we did earlier. And also you find g composite f of a function. Okay, you find f composite g, you find g composite f. And if you get x as your final answer, so once you find f composite g, g composite f, and if you have x as your final answer, okay, if you have x as a final answer for both of these expression, your function are inverse of each other. Okay, That's all you need to do. You find F composite G, you find G composite F, and if you have to have X, okay, if you have negative X, no, you have to get the X. Then the functions are inverse of each other. So in the similar, we can do number 14. So I'm skipping. Is it okay if I skip this part here, finding F composite G and finding G composite F? Okay, so try to solve this one. Okay, finding composite. Okay, in number 19 and 20, you have the table given to you and you have to decide whether the function is one-to-one or not. And how do we know whether it's one-to-one or not? So to be a one, so let me give a different example and you should be able to do for 19 and 20. So for 19 and 20, so you are asked to decide function is one-to-one or not. So let's say we have a set X, we have a set Y. Okay, to be a one-to-one function, okay, every element from set X, let's say we have -2, 4, 3. Okay, so every element from set X must have unique output. Okay, so let's say we have A, B, C. -2 corresponds to A, 4 corresponds to B, 3 corresponds to C. Now here, -2 has its own unique output A. 4 has a unique output B. Okay, unique from is different from A. And 3 has a unique output C. And if you have every element from your X, from your domain, okay, with a unique output, then it is a one-to-one. If you have something like this, for example, if you had 3 corresponding to B, now this is not one-to-one because 4 and 3, it has the same output. So this does not make this is a function, but this is not one-to-one function. Okay, so to be a one-to-one function, every input of your X has to have unique output. So using this concept, you should be able to do number 19 and 20. You have a table, you just decide whether this is a one-to-one or not. The next, from 26, 28, 30, 26, 28, 26 and 28. So you have a graph there. So in 26 and 28, you have a graph there. And you have to decide whether the graph is one-to-one or not. And what test do we use to check whether the graph is one-to-one or not? It's a horizontal line test. You draw, like for example, you have a graph like this. Let's say your graph is like this. And you want to know whether this graph is one-to-one or not. Okay, so what we do here is that you draw a horizontal line. And if this horizontal line crosses more than once to the graph, it is not one-to-one. So the graph crosses at 3 points. So this graph is not one-to-one. Okay, so that's 26, 28. The next we have 30, 32, 30 and 32. So we have 30, 32, and 34. No, 30 and 32. So here in number 30 and 32, you have a function and you have to state whether this function is one-to-one or not. Okay, let me do one. You have 30 and 32. Okay, so let me pick number 30. So our function f of x is 4/3 x plus 1. And you have to decide, you have to verify, okay, not only deciding whether this function is one-to-one. This is not enough. You have to show that this function is one-to-one or not. And for that, what you're gonna do here is that you're gonna pick any two inputs, two different input. Okay, let me call my inputs are x1, x2. You can say A, B, or like P, Q. Okay, so let's say our inputs are x1, x2. Okay, So you have a function and you have to verify that function is one-to-one or not. So the very first step is that you choose your two different input. Okay. Now you have to verify. Now you choose your any two inputs and let's consider the output for these inputs. It means f of x1 is equals to f of x2. Okay. You choose two different input. Okay. Your inputs are different. But let's consider the output for these inputs are same. So f of x1 is equals to f of x2. Okay. Now let's find this f of x1 and f of x2. So what will be f of x1? To find f of x1, you substitute x1 for x in your f function. So we have 4 over 3 x1 plus 1 equals to, you substitute, you need to find f of x2. For that, you substitute x2 for x in f function. So we have 4 over 3 x2 plus 1. Now let's subtract 1 on both sides. This is gone. This is gone. We have 4 over 3 x1 equals to 4 over 3 x2. You multiply both sides by 3 over 4. 3 over 4. So 3, 3 cancel, 4, 4 cancel, 4, 4 cancel, 3, 3 cancels. So we have x1 equals to x2. See how we started? We started with a two different input. We didn't know that x1 and x2 are exactly same. We had a two different input, okay, but we consider their outputs are same. We had inputs different, but the outputs were same. So we started from assuming that their outputs are same, and we end up getting the input also are same. And if this condition is satisfied, your function is one-to-one. So f is 1-to-1. Sometime you may not get x1 equals to x2. And if you don't get x1 equals to x2, then the function is not one-to-one. Okay. And this is the way. I think I'm not sure, but I think you have a one very similar problem on your exam. Okay. You have a function given to you and you are asked to verify that the function is one-to-one. And this is how you do. You start by taking two different input. Okay. Assume that your outputs for those inputs are equal. And if you end up the inputs are also same, the function is one-to-one. If the inputs are not same, the function is not one-to-one, and you will have a very similar problem. Does
There's something that I just don't understand about this, and that's that if the two inputs are the same, then how could it be a function, or like how could it be a function if two different inputs are the same?
Okay, now here, for example, so what we had, x1 and x2 as a two different input, right? Now we assume that their output, the output for f of x1 is f, so the output for input x1 is f of x1, and the output for x2 is f of x2. Initially, we had x1 and x2 different, but we consider their outputs are same. Okay, this is what we consider. Now, when we start solving, what we found x1 is also equals to x2. Okay, so initially, so we had this mapping. So we had x1 mapping to f of x1, which is same as f of x2, and x2 corresponding to f of x2, which is also same as f of x1. Now, does this make your function one-to-one initially? Is it one-to-one function? To be a one-to-one, they must have a unique output, right? But they have a exactly same output. Now, when you solve this here, we end up getting x1 is same as x2. Now, when your x1 is same as x2, we don't have this one. And our x1, x2 corresponds to f of x1. And we end up getting our one-to-one function. Does that make sense?
No, I'm still lost, but
Okay, let's try one. For example, so you have a different output. Let me call A, B. So these are two different inputs, okay? The output for A, f of A, the output for B, f of B. Let's say their outputs are same. We just consider, we don't know whether they are same. Okay, we assume that their output are same, but the inputs are different. Now, if this is the case, A corresponds to f of A, B corresponds to f of A. Now, is this function one-to-one or not at this condition?
it is, but
No,
how is it if
is it
they
one-to-one?
both
No, this is not one-to-one. This is a function, but this is not one-to-one. So
it's a
to be
function,
one
but
to
it's not a one-to-one.
okay, to be one-to-one, you must have something like this. F of A, they have f of B has to be different. A corresponds to f of A, B corresponds to f of B. The output has to be unique. So this is one-to-one. But here, this is not one-to-one. Okay. Now we assume their outputs are same. When we assume their output are same, we end up that when you solve similarly like we did earlier, you will end up getting A is equals to B. It means A and B, they are exactly same. Okay, so you don't have two different input here. You have one input, which is A or B. So these two corresponds to one. So you have one input, okay, with its unique output. And A and B, they are exactly same. It's the same number. And it is mapping to exactly one unique output. And that makes the function is one-to-one. Did that help you, David?
I might have to get some more on this like later.
Okay, but if you have any more questions, you just let me know, okay? Now,
Okay.
let's continue from here. So we did, so I have like 6 minutes in this meeting. I need to extend this one. Okay, so we are at 30, I don't know, okay, now 50, okay. This is number 30. So we still have, let me give you a hint for these, okay, 50, 52, 53, 54. You are not required to graph, and there is 62. Let's see what we have here. In 50, oh, finding the inverse. Let me do one, okay? And I think the remaining you should be able to do. So 50, you have a function g of x equals to x plus 2 squared. Okay, so this is the function, and you are asked to find the inverse function, and you will have one problem asking for finding inverse. So first step is that you replace your g of x, or sometimes you have f of x, sometimes you may get h of x. First step, you replace this output by y equals to x plus 2 squared. Okay. Second step, you are interchanging x and y. So for x, you're gonna write, sorry, for y, you're gonna write x. For x, you're gonna write y. So we have y plus 2 squared. First, replace your g of x or f of x by y. The next, interchange x and y. So for every y, you're gonna write down x, and for every x, you're gonna write down y. The next, you are solving this equation for y. Solve for y. Okay, so to solve this equation for y, you need to get rid of this square. Okay, so getting rid of square means you get a square root here on the left. So we have a square root of x equals to y plus 2. You subtract 2. Square root of x minus 2 equals to y. And once you have solution for y, you replace your y by f inverse x, which is square root of x minus 2, and this is your inverse function. And you'll have this question, okay, like very similar one. Does anyone need help here for number 50? 52 is same, so I'm going to skip. 53 is same, I'm going to skip. 54 is same, similar, not exactly same, I'm going to skip. 62, what do we have in number 62? Oh, find the inverse of the given function, then graph. You don't need to graph, just find the inverse function like I did here for 50. Okay, you replace your f of x or g of x by y, interchange x and y. For y you're gonna write down x, for x you're gonna write down y, and you solve the equation for y, and the solution of y is your f inverse function. I think, yeah, that's all. The 62 is also, you have a different function, but you are asked to find the inverse, and you are not required to graph. I think you should be able to solve this one. Now, do you have any question? I think we finished the review session. Do you have any question? Nancy, Lauren, David, you are here, so if you have any question, I will take it.
Is there any way you can do 53?
I'm sorry,
Is there any way you can do 53?
53?
Yes.
Okay. Yes, but I think I do have 2 minutes. Okay, let me try to finish. If not, I will start new meeting. So in 50, you said 53, right?
Yes.
Okay, 53, we have f of x equals to 2x, x minus 1. You replace f of x by y equals to 2x, x minus 1. You interchange x and y. For y, you write down x. For each x, you're going to write down y. Now you are solving this for y. Okay, to get rid of this denominator, multiply both sides by denominator, y minus 1. This is gone, this is gone. So you have y minus 1, x equals to 2y. So you have y here, you have y here. So you have to collect all y's together in the same side. So let's distribute x. X times y, xy, x times negative 1, negative x equals to 2y. This has y, this has y. So let's collect y together. So this is gone. Negative x equals to 2y minus xy. Okay, so we have y here. So let's factor out y. So once you factor out y, you have 2 minus x. Now we need to get rid of this 2 minus x, divided by 2 minus x. So negative x divided by 2 minus x equals to y, and this y is your f inverse. So this should be negative. This is not -1, but should be negative here, okay? And this is your f inverse x. I did very fast. Do you have question here? You are solving for y. If you have any question, I will start new meeting. If not, it's about to end. We have like a very few seconds. Does anyone have question? If you don't have any question, we are done. If you have question, please let me know. We have a less than